Okay, thank you, Lunara. On behalf of the Chemical Materials Engineering Department, I would like to welcome everyone to this session, where I will try together with good colleagues to present the programs offered by the department. Give me 1 second to share my screen. Let me decrease this one. Remove meeting controls so that I hope we don't have SEDS for the recording. And as I'm also the director of the undergraduate program, I will try today to give you shortly an idea of the chemical and materials engineering profession, career, a good insight in our department research and our graduates. I promise to try to be short. Let me check my time so that we can give you a very good idea of curriculum and programs without being boring and extensive. So, first of all, chemical and materials engineering is the engineering discipline which makes use of scaled up, and please pay attention to scaled up, chemical and physical transformations in order to turn raw materials into useful and marketable products. Or to put it shortly, we are trying to improve the quality of life by utilizing chemical and physical transformations. And how we do this? We take natural resources, we apply principles from many fields, chemistry, math, physics, biology, but also economics. Don't forget, we have to give solutions that are financially feasible in order to design and give all these products that we are using in our daily lives. And as I said, pay attention to the scaled up. This is our main difference to the chemistry department. We have to move a process from the lab to the industrial scale. Let me make a comment that all the pictures that you see are actually from our own students, okay? And some people, they believe that that's it. There is no any room for further progress, but this is not true. Daily, we have to take into account new needs, new restrictions, and as you well know with COVID now, new challenges. So we have to work for environmental remediation toward zero emission factories to develop new materials for any field, okay, and assist in the research for pharmaceuticals and mineral processing. And all of them, okay, to serve the needs of our society. And 3 years ago, if I'm not mistaken, we renamed the department from the typical, let's say, chemical engineering to chemical and materials engineering department. This happened for 2 reasons. First, to depict the variety and of the research and expertise in the department. But at the same time, we wanted to follow the current trends in relation with the progress in materials. Check these 2 aircrafts, yes, from the same company. I think that the difference in the production date is around 10 years. The first one on the left, the typical 777, is mainly made of steel. But taking a quick look on the right side, you will see now that the new Boeing is composed of mainly composite materials. Okay, new advanced materials that take advantage and try to combine, okay, the properties of many different materials. Let me focus on the profession and the career now. Chemical engineering, you know, profession is growing globally one. You can have career flexibility, good money, and you know, you can follow your own lifestyle. What I mean, you wish to work in small companies, you can do it. Big companies, you can even start your own company. You can work globally, locally, sorry, or you may choose to have a more adventurous lifestyle, traveling and working globally as our good student that you see on this picture. And there are many employment opportunities in petrochemical industry, materials, biotechnology, environmental services, food and drink. You can combine your studies with a master's degree in finance and follow the relevant field. And all companies worldwide, they need a chemical engineer. Many of our students choose to work or study abroad. And the USA, you know, is a top option. I will show you quickly some statistics. You see that chemical engineering is #1 regarding the starting salary, okay, without any other degrees. We are on top of everyone, okay. And what happens, okay, in time? Is our salary stagnant? No. You see, there is a steady increasing trend regarding the salary. Okay, I chose USA because you can easily retrieve statistics. And as I always say to students, if you don't believe me, you can always use the US Bureau of Statistics or sites like this one, Salary Explorer, and to verify this information. And your experience, is it going lost or is it useful for your own benefit? You see that after 5 years of experience of working in the field, you are able to double your salary. Okay, this is very important because some people, they get a good job, but they don't see a vision, you understand? A progression. Check this one. You may say, should I go for a graduate degree or not? I think that directly you can see the advance in your salary in case you obtain a master's or a PhD degree. The difference is enormous. And there are some stereotypes sometimes, you know, or at least I hope in the past, that women are not for engineers, or if they try to choose this direction, they will have problems in the job market and so on. And okay, even in the USA, there is a small decline between salaries for males and females. But if you check here on this table, you will see that on general, okay, women can also have a very successful career, at least as depicted by the average salary. You see also some other statistics based on January 2021. If you check the mean annual salary, we are on top of everyone. Allow me to say that we are second only to doctors. And of course, there are many job positions. If you check for both biomedical engineers and chemical engineers and material engineers, if you see them, the number combined, you will see that if you follow our programs, there are many also job openings. Because, okay, if there is only one position like the President of America, yes, it has a good salary, but there is, it is an opening just for one, okay? So let me skip this slide and show you that we have even chemical engineers in space, Cevat. Okay, and the meaning of this slide, of course, is not that I will travel to Mars. I'm too old for this, but that whatever you choose to do in your life, the path that you are going to follow, okay, this diploma will give you a solid background and reputation to follow your dreams. And by 2025, don't forget, the whole population will be over than 8 billion people, which is a huge number. And new materials and better processes are to be showed if we wish to continue, okay, the life that and the lifestyle that we lead on today. And chemical and materials engineering is at the center of a new industrial revolution where economic wealth goes hand in hand with environmental and social sustainability. Don't forget this. It's not only about money, it's about our life and well-being. And regarding Kazakhstan, you should all know better than me that, let me show you, is in top 15 countries regarding oil reserves. Okay, this is well known, yes. But the Chang-Keun, check. The country has the second largest uranium, chromium, lead, and zinc reserves. And if you are not convinced, it has the 5th largest copper reserves. It is in top 10 for coal, iron, and gold. As people say, 95% of the periodic table is found underground in Kazakhstan. Okay, and we have a responsibility, Chang-Keun, to transform, okay, to exploit, okay, these reserves into the marketable products that I spoke at the beginning of this presentation. And if you are not convinced by all of this, okay, personally, it has fun, okay, to work as a chemical engineer, to be in the lab, to study with us. And now, why chemical and materials engineering specifically at Nazarbayev University? You know that we released the first batch of graduates back in 2015. And since then, we have strengthened our programs and developed 4 of them. The one at the graduate program, 2 at the master level, and 1 at the PhD level. The department has 1 professor, 7 associate professors, 8 assistant postdoc researchers, teaching assistants and lab assistants, and all instructors hold PhD diplomas from world leading universities. And our curriculum now is designed and based on American standards. So we have 4 years. The first one, I would say 1.5 years, are common for all engineering programs, okay, including mainly math, physics, some programming and introduction courses. But as we progress, you will see many core chemical engineering courses in the program, like separation processes, chemical reaction engineering, and at the end, the capstone project, okay, the jewelry, let's say, in our program, where the students will be called to design from scratch a real industrial facility. And at the same time, we have a good number of elective courses so that you can, let's say, shape your own program and give your personal taste. And we are trying, with the help of faculty, to offer as many elective courses as possible, okay, to accommodate all tastes. This is a general scheme of our curriculum as we progress from the 1st to the 4th year of the undergraduate chemical and materials engineering program. And we have very good labs, very well equipped. I would say we have top labs, competitive all over the world. And the students have actual access to these labs. They have the chance to participate in international conferences. Okay, now we have some restrictions related to COVID, but I believe pretty soon we will resume a normal operation. And of course, our students have the chance to conduct top research of top quality in any field. You see, there are 4 general categories: energy, bio, environment, materials, but not only restricted to these ones. But I will not talk about research because I believe that my colleagues will have the chance to provide you with better and more juicy and hot details about this. But you should know that most of our students publish before they even take their bachelor diploma. And we perform both basic and applied research, okay, that it is relevant to our society, as you see, okay, in this slide, Professor Bakeno. If you need any further details about the faculty, the labs, the courses, our programs, you can always access our website. I think this is at a very good state, providing a lot of information. And of course, we are always working on this. Do not hesitate to contact me or any faculty member. And I'm not going to show you detailed statistics. I don't want to be boring. I would like only to mention that almost all of our graduates find a position. Let it be work or further studies, locally or abroad. And regarding further studies, because maybe you don't know, let me read the options of our of 25 recent graduates. Okay, where they continued after Nazarbayev University. The numbers are real. MIT, Stanford, Berkeley, Boston, Cornell, Pennsylvania, UCL, Manchester, London, Tokyo. Okay? So you see that although we are a young university, we are trying to develop a brand name that will be respected, okay, by other academic institutions, but also in the job market. And I have some slides, yes, about student life, about our chapters, research opportunities, and our students in the field. But I think at this point, it would be useful to call Arslan Yunisov, a fourth-year undergraduate student, to share with us his own experience. Arslan.
Yes, hello, Professor. Hello, everyone. Can you hear me well?
Yes.
Okay, good. So, okay, so yes, I will show the same slides, but I will mainly focus on my personal experience. So let me first introduce you to the popular meme about chemical engineering. So usual college students, they have two options out of three. In the sacred triangle, and chemical engineers can only choose one and fail at it. But I will prove this meme wrong. So let me start with the student life. Nazarbayev University has more than 100 social clubs, and I was a part of several of them. For example, I was a minister at the student government, and I worked on the research problems in our university. We did some interviews with professors. We solved some issues with chemicals, for example, in SST and other blocks as well. And we also interviewed our school head of the school, and we asked about the problems and about procedures that students have to follow to get sponsorship or other financial aid for his or her traveling, etc. So we was a bridge between university and students. There are many clubs, for example, art club or orchestra. So you have plenty of options. If you want to go to any of the clubs, they will accept you without any doubt. But we also have some clubs that are related to our major. For example, Nazarbayev University SPE student chapter, Nazarbayev University AICHE student chapter. These are official student chapter as well as Institution of Engineering and Technology. So they have contact with global organizations, SPE, AICHE, and IT. And they organize some events. I was the president of No AICHE Club in 2 years ago, and we organized events for students related to research opportunities, internship opportunities, no alumni talks, and other events as well. So if you want to be involved in social life related to your major, then again, you have many options and you can choose among them, and you can develop professionally and personally as well. You can find new friends. And since you are on the same major, you will become lifelong friends. Maybe you will even work in the same place in the future. Our school and our department also provides and some industrial internship opportunities, which will help you get the jobs of your dreams. So here you can see our students from our department who worked in Shell, Food Masters companies, or TCO, and other companies as well. So these are major oil producing companies, not only in Kazakhstan, but also around the globe. So it's a very good experience for you to do such internships and then be accepted for the job. And since, as Professor Poulopoulos just said, you will have very high salaries in these companies. But if you don't want to go to the industry, you can go and do research. For example, we have really good labs, and I'm personally a research assistant of Professor Poulopoulos, and I have done some projects with Professor Shah as well. So you can go even in the first year and talk to professor, and then do research and see if you like it or not. If not, you can go to another professor. It's okay. And we have published 2 articles now with Professor Poulopoulos, and we are planning to publish more very soon. So it's a very good option if you want to continue your studies and go to a master's degree or even PhD. I know some students who went to a PhD program right after the bachelor degree. So this research opportunity at Nazarbayev University, and specifically in our department, I think helped them a lot. And again, these are all our students, not some other students. And such opportunities like internships and research at Nazarbayev University will help you get even bigger opportunities. For example, traveling around the world by some programs, or get sponsorships from some foundations, or study during the summer term in, again, world-leading universities, for example, Wisconsin Medicine or University of Buffalo. And this experience is very unique and interesting. You can see here me on the left, right, on the left bottom corner. I went to Lawrence Berkeley National Laboratory this summer and previous summer, and I worked there for 2 months on a project related to material synthesis, and it was a really interesting and fascinating experience that not only helped my CV and the like my skills, but also it helped me personally because I went alone, and it was a real challenge for me to live there, but I think it really helped me develop personally and help my spirit grow and other things as well. So if you want to join our department, then I guess you'll have such opportunities as well. And here you can see USA or Europe, and yeah, I think it's fun, right, to have such opportunities. But apart from studying and apart from looking for opportunities and getting them, it's also very important to have rest. So because you will be involved in research or in social activities, you will have some friends with whom you have you will spend your time with. So it's very good that university has such options like student clubs, or it allows students to participate in conferences or research activities, because it also helps you, and then it will help you throughout your life from now on. And based on all of that, I decided to change the meme, and I decided to say that at chemical engineering at Nazarbayev University, you can choose all three and even get an extra one, but still it's all up to you because no one guarantees you success. So if you work hard and push yourself to your limits, then you will achieve lots of things and you will get the best opportunities of your life. Thank you.
Arslan, let me ask you, yes or not? Did you publish?
Yes.
Do you have more works to be published?
Yes.
Did you participate in international conferences?
Yes, 2 conferences.
Did you go to Berkeley?
Yes.
Did you participate in the American Institute of Chemical Engineers chapter as a president or for other positions?
Yes, yes.
Did you perform research?
Yes.
Did you have any problems to conduct all of this?
No. Just
I mean,
like
did we have to use the president of America to help you? No. You did
No,
all of this
no.
on your own. Okay.
And with the help of the department and professors here.
Okay, please stop sharing your presentation. And one second to remove all of this. I'm not going to take much of your time showing quickly of our students in many countries and universities all over the world. Okay, and just to say that chemical and materials engineering department is the greatest place to start your career, and join the future, study chemical and materials engineering at Nazarbayev University with us. Thank you very much for attending the first part, and Chang-Keun, the floor is all yours.
Okay, can you see the screen?
Yes, we can see.
Okay, let me introduce the master program in science in chemical and materials engineering. So shortly, MCHME program. So let's see the overview of the MSc program in chemical and materials engineering. So the program goal is providing its graduates with the skill required for innovative chemical and materials engineering to translate research into production and to foster the future technological development in the country and abroad. And the program aim of the MCHME program is like this. So educating students with engineering expertise to lead organizations and provide innovative solutions for complex technical issues of enterprises. Conducting innovative and pioneering basics of applied research that evolve the body of knowledge in engineering through interdisciplinary collaboration with other schools and research centers at Nazarbayev University and leading university worldwide as well. And advancing the professional development in engineering through our service to professional community and providing lifelong learning opportunities for practitioners. So here, yeah, there is a requirement for the MCHME degree. So for the master degree, you need to complete 120 ECTS in 4th semester, including 5 advanced core courses that they are the applied mathematics, hidden mass transfer, materials processing, material characterization, and chemical reaction engineering. And another 3 additional core courses also there, and you need to complete 4 elective courses as well. I will show you that the elective course pool later. And yeah, the important thing is, things are here, the master thesis based on your research. So the program course plan is like this. So in the first semester, there are 5 core courses, and the second semester, 3 core courses and 2 elective courses you need to complete. And then from the 3rd and 4th semester, more than half, so most of the time you will consume for preparing your master thesis. So which means actually you are in that 2 semester wholly, you need to consume your time for the preparing your do your research and preparing the master thesis. That is big difference between the undergraduate course and this master course. So here we can see the program elective courses, computational study for the chemical and materials engineering and thermodynamics and biofilm science and engineering and oil processing and safety and risk engineering, environmental courses and polymer melt fluid mechanics and processing and advanced powder processing and porous material, porous and powder materials characterization, and some advanced material for environmental and biomedical applications, and advanced energy materials and their application, and computational material engineering and air toxicity, air quality toxicity, and health. So in these large pool, you can select 4 elective courses, and it's totally depend on your research interest. So here, yeah, the big difference in master program is that the research and the preparing that the master thesis. That's why, yeah, I will show you that the roadmap of master thesis here. So first step is identify thesis supervisor. So you can contact to your, depend on your research interest, you can contact to faculty in our department, and you can select your thesis supervisor. And with discussion with your thesis supervisor, you can select a research topic, and then you need to submit your thesis proposal in the 3rd semester of your the master program, and then carrying out research and preparation of thesis. And at the 4th semester of your master program, you will submit master thesis, and it will be evaluated, and you need to present your thesis result, actually, research result as well. So there are many research opportunity in our department. They are including energy generation, conversion and storage, and environmental protection, remediation, and resource efficiency, and process design and simulation, and functional material also included. So here, yeah, we already saw this figure. So yeah, our faculties are researching in kind of big categories, actual energy and bio and environment and materials. So I will show you kind of brief introduction in research in our department. First one is environment. So Professor Stavros Poulopoulos are doing this environmental research with students for the emerging pollutant, and even his group are evaluating decoupling of GDP, energy, and carbon dioxide emission as well. So, and not only the Professor Stavros Poulopoulos group, another group also doing some environmental protection. So Professor Jorge Ruales is prediction. He's doing the prediction of carcinogenicity of the polycyclic aromatic hydrocarbons as well. And another topic in our department, research topic, is the energy storage. So we have 3 faculty in our department who is conducting the energy storage research, mainly the lithium-ion battery or lithium sulfur battery. So Professor Bakhenov, Professor Mentbaeva, and Professor Konarov are doing are developing next generation energy storage or solid batteries, high energy density electrode materials, and advanced ion conductive membranes for energy storage and conversion, and energy storage device and the control system. And especially for my research field, this is my research field is energy transforming and optoelectronic materials for the energy material and or kind of LED or another the material for optoelectronics as well. And in food industry also, Professor Sergei Sportar is researching on the smart drying opportunity to make food in the dried food in the system. And some computational studies also in various research fields. One of the research fields for the computational studies, advanced material modeling of the manufacturing processes, porous structure, and the transport properties of powder compact for production of advanced material. That this kind of research is conducted by the Professor Boris Gorman in our department. And the chemical engineering process also simulated by the Professor the Dawai Shah to have efficient kind of to design efficient chemical process with actually kind of software Aspen Plus. And the material simulation also we are doing by the computational study. So they are developing advanced technique in theory, modeling, simulation, and informatics to understand materials and accelerate design and the discovery of new materials as well. So that's all it's actually not that all, that they are just part of our research topic, and among them just some of them only I just presented in this presentation, and maybe so you have another topic as well, but actually the big topic is energy, bio, and environment and materials in our department, definitely. So that's it for my presentation. It's very short, but let's move to the next presentation from Professor Cevat Erisken about the biomedical engineering master program. Okay, I will stop share.
Okay, great. Thanks, Chang-Keun, for the introduction, because I will not go over the same procedure. So what we have in biomedical engineering program, actually, in terms of like PAB, or what you're supposed to do like at the end of every single semester, is pretty much the same as the case in chemical and materials engineering. Okay, so I'll not be going into details on that. Instead, I'll try to give you some information about biomedical engineering and applications of biomedical engineering. Let me start, for those who are not familiar with biomedical engineering, let me start with the quick definition and applications of it. So what is a biomedical engineering? What is biomedical engineering? Okay, so it is the application of the principles and problem-solving techniques of engineering to improve human health. So we're doing, like as in the case of many other engineering disciplines, but the purpose here is to improve human health. Okay, so what do they do? What do biomedical engineers do? They design, develop, and test all aspects of medical and surgical instruments. Okay, so they analyze failure, corrective, and preventive action to respond to customer complaints. Okay, so they work with cross-functional teams to test prototypes, and also they demonstrate the operation of equipment to medical personnel. They develop these equipment or instruments, and they are also supposed to demonstrate the working principles of these instruments. So a brief slide about the courses in biomedical engineering. Again, you are supposed to take like 30 credits in each semester, a total of 120. We have elective courses like must courses, core courses, as you guys see in this slide. So if you are interested in details, you can just go to the website. We have a handbook explaining all the details. So you can reach the handbook or other relevant information just logging into or going into the website of biomedical engineering. So in addition to the core courses, we also have elective courses. Okay, so these are like strategies for controlled drug delivery, medical device technology, infectious disease, biomedical imaging, and mechanics, biomechanics. Okay, so these are the elective courses. We have a total of 4 elective courses, and you are supposed to take at least 2 of them from the Department of Biomedical Engineering. So what are the main fields of biomedical engineering? We have biomaterials, physiology, biomechanics, imaging, regenerative engineering, bioinformatics, rehabilitation, biosensors, instrumentation, and bioprocessing. So of course, you can just add some more to this because biomedical engineering is an interdisciplinary field. It involves many other disciplines and they work together, combined fashion to actually improve the outcomes of biomedical engineering. So biosensor, I'm going to just talk about those we are actually having research-related activities at Nazarbayev University. So biosensors, it means you have a recognizer and then you also have a converter. Okay, so first the bioreceptors, they recognize the target analyte, and then they convert the recognition into a quantifiable signal so that you can see what is going on. The related fields are medical diagnosis, pharmaceuticals and replacement organs, biological warfare agents detection, and so on. So these are, of course, some of the examples. So we are working on fiber optic biosensors at Nazarbayev University. We are also using thermal ablation. So this is a novel and minimally invasive approach to cancer care. Okay, so you first detect the presence of cancer cells, and then you just try to remove it. You just decrease the volume first, and then finally, following cryoablation, you can remove the cancer. If you're interested in more details, you can certainly contact the relevant persons. The other field is biomaterials. Materials, these are the materials that do not lead to adverse reactions when in contact with tissues or organs. We call these biocompatible materials. So we have so many devices that are used in the body, like joint replacement devices. Okay, so this is a, oops, sorry. So the joint replacement devices, you see in the picture that, you know, we have this joint, okay? So if the joint is no longer functioning as expected, we have this device, knee replacement device. So this serves as the upper portion serves as the femur, the bottom portion serves as the tibia. These are all made from biomaterials. They could be like ceramics, polymers, metals, or composites, combination of multiple materials. So biomaterials are used in heart valves, artificial tissues, organs, dental implants, bone implants, stents, and in many, many other applications to improve human comfort and health. Biofilms is another application. So when we use those biomaterials in the body, okay, they may actually be prone to infections. So when we have infections, at the first stage, we just have the adherence of the contaminants. Then they initiate the process of proliferation, multiplication. So they multiply, they become really a lot in numbers, and then they maturate, and finally they start dispersion. Okay, they disperse, they distribute, they're distributed all over the body. So biofilms are really critical in this field, and we have to remove them at the very beginning of their, you know, at the adherence stage if possible. Imaging is another part. So it is the combination of physical phenomena with data processing and display. Some examples of imaging are X-ray, okay, computed tomography, ultrasound, and MRI imaging. Of course, these are non-destructive imaging techniques. We also have destructive techniques, but unfortunately, we cannot use them for humans. We use them for like animal studies or in vitro work. We need to, in biomedical engineering, there's a huge need in developing new techniques. We have these, but the major problem with this is the resolution. Okay, you want to see them in micron level. However, it is really hard to do that with the current technology. So imaging is a huge field, open field actually in biomedical engineering. In our program, we're working on therapeutic and diagnostic materials. So first, you see what is there, you diagnose if there's a disease and then you try to treat it, okay? Bioinformatics, this is another important field in biomedical engineering. So it is the field of science in which biology, computer science, and information technology all merge together into a single discipline. So the global bioinformatics market is projected to reach more than $20 billion in 2026. Okay, in 2021, it was around $10 billion. So there's a huge increase in the market related to bioinformatics. So what the bioinformatic is actually tries to mimic, to biomimic the products, the biological products, actually using some engineering techniques or computational techniques. Okay, so biosimilarity. There are so many companies in the field. These are, of course, some of the big companies in the bioinformatics industry. The other field is regenerative engineering or tissue engineering. So this field aims to regenerate the tissues, the diseased tissues. If biomedical devices are not working properly, it is better to regenerate it. When you regenerate the tissue or organ looks like exactly the original tissue. It is the application of biological, chemical, and engineering principles towards repair, restoration, or regeneration of tissues using cells, factors, and biomaterials, either alone or in combination. Okay, so we have cells, biodegradable materials, and we also use biomolecules to form a structure in vitro similar to the native tissue, and then it is implanted into the body. So basically, regenerative engineering implies that the quality of human body could be improved by repairing or replacing its parts, just like it is done for a mechanical device, such as a car. In biomedical engineering program, we have 3D printers, okay, 3D printers or bioprinters to be used for bone tissue engineering, for example. We have faculty members working in this field. And also I am working in a similar field like meniscus regenerative engineering. What we do, for example, we have a sheep meniscus here. So it is actually extracted, harvested from the sheep. And then using 3D design, you just have the exact shape of the meniscus. And then using 3D printers, you can just print exactly the same shape. What you do then, you simply put your scaffold or biomaterial, okay, to replace the disease, the damaged tissue. And what you see here, actually, after 6 weeks of replacement, you can clearly see that this is, oops, is it working? Let me see. So this is the sheep where, is it not working? It's not working, I believe. Well, let me try this way. I don't want to use spend time. Yeah, you see on the left knee, after 6 weeks of replacement, the sheep is actually, the knee of the sheep is actually functioning pretty good. So the sheep can perform daily activities. So what are the career options in biomedical engineering? You may go to industry. Oops, sorry. You may choose going to industry. You can choose pursuing a higher degree or doctorate degree, PhD degrees, and so on. In industry, you can do like consulting. You can work in government agencies, hospitals, medical device companies, pharmaceuticals, and any activity related to sports medicine, okay? So this table actually shows you the position of biomedical engineering in other disciplines in terms of undergraduate, master's, and PhD levels. So as you see here, the red colored ones are the top 3. We have biomedical engineering and chemical engineering, biomedical engineering again, and biomedical engineering again. So biomedical engineering has always been at the top 3, okay? So we have the comparison for years 2008, 2017. So it is performed like every 10 years. So unfortunately, I don't have data for the next cycle. But biomedical engineering is always, you know, at the top 3. Okay, so I would like to stop at this point, and any questions will be, of course, appreciated at the end of the presentations. Next is Nurxat. I believe he is going to be talking about the PhD program in chemical and materials engineering.
Thank you, Cevat. So let me share my slides. Okay, how many minutes do I have, Stavros? You're always challenging me.
You have 15 minutes, I believe, easily.
Okay, good. Thank you, Cevat, for a nice introduction. So I am going to talk about PhD program. Before me, my colleagues introduced the bachelor program, also master program. So now I am going to talk about PhD program in chemical engineering. So PhD program is actually established in 2019 as officially executed 2020. So aim of this program is to develop high quality doctoral researchers are ready to and able to make lasting contribution to address scientific, technology, and economic, society, environmental challenge of global significance. This program is closely associated with the aim of Kazakhstan to increase its global competitiveness and join top 30 most developed country in the world by 2050. So the aim of this program is to develop specialists for advanced career in industry, academia in Kazakhstan and worldwide. Also, this program also aims to develop, prepare future policy and decision makers for careers in governmental agency, public service, and the social economy in Kazakhstan and globally. Entrepreneur, another target. This program also aims to prepare a new generation of commercially available, aware, and technologically advanced science and technologists to lead future development in choosing chemical and materials engineering subdiscipline. So this program also targets to prepare future academics and researchers in chemical engineering subdisciplines for careers as specialists in the University of Kazakhstan and the other parts of the world. So this program has outcomes. So expect outcomes, the students should have ability to review and analyze, evaluate the scientific literature in the field of chemical engineering. This students is able to select appropriate research topics in the field of chemical engineering and generate hypotheses about these topics. The students also has ability to plan, develop, analyze, communicate research in the writing and verbally independently. And last, fourth outcomes for students, we are expecting students to make original contribute to knowledge in the area of specialization in chemical engineering. Students should have an ability to judge technically and ethically related research to a broader field of knowledge in chemical engineering. The last outcome from this program is that students is able to develop their academic and scholarly careers through presentation, publication, national and international networking. So the PhD program is a little different from other programs. So our recruitment process is administered by 2 units. One is the Nazarbayev University Admission Office, and another one is the PhD Admission Committee. So students need to submit this following documents. First thing, they need to fill up this form before the deadline and then provide cover letter. And then they also need to provide certificates of like master science and bachelor science. So English proofs is also required. We also required to have 2 recommendation letters from their supervisors or advisors. And they also need to submit a resume. This committee, after reviewing this document, this application package, they will select candidates for like personal review. Finally, they will provide offers acceptance letter for students. This is the admission process for PhD program. Okay, so we have also requirement for PhD students. After students' involvement, they required to finish at least 240 ECTs to get the complete PhD program. So here 62 actually in total course, 178 ECTS in the research works. So first year course shown in the slides, like first year students needs to take 2 core courses from our department and 1 course from at the school level, and then also 2 elective courses from our department. And second semester, students needs to take 4 core courses from our department. So 1 elective course. So here's all of the list of the courses in our department. So 5 core courses is advanced chemical engineering thermodynamics, chemical reaction engineering, and heat mass transfer. Another one is current research literature. And then we also listed like elective courses, but this list not updated yet. And the second semester, after they finish like first year courses, students needs to conduct their research. And then at the 8th semester, students needs to get 178 research credits. Students requires to register at least 24 ECTS per semester. Maximum is the 36 ESTS. Okay, this is a roadmap for students to complete PhD program. First thing, students after enrolling PhD program, they need to find out their supervisors. This happened usually like first 8 weeks of second semester. And then after they filled up this form, supervisory committee form, at the end of first year or end of the second semester, students will take subject qualify exam. After they pass the subject qualify exam, students allowed to take research qualify exam at the end of third semester. And then students' research progress reviewed by progress review committee annually. And the last semester, like 8th semester, students' PhD dissertation will be reviewed by Thesis examination committee. So our department also have a department graduate program committee. This program is responsible for establishing first supervisory committee for each student. So they has to approve supervisory committee. So supervisory committee consists of leading and the co-external advisors. So this thing should be happen end of the first semester. And then this committee is responsible for their students' research. They are supervised students' research. And second committee for each students approved by DGPS, DPC, so progress review committee. This progress review committee is in charge of evaluating students' research qualified exam, also annual progress in their thesis. Usually head of this one is usually head of this progress review committee is should be head of the graduate program committee. So, and the third committee established by this DGPC for each student is thesis examination committee. So thesis examination committee will check student dissertation, and they are also responsible for students' thesis defense. So this committee includes one external examiner outside NU. Okay, so students, in order to get complete this PhD program, of course, they should have good standing. So they should have CGPA, cumulative GPA has to be higher than B-. And then students required to pass subject qualified exam end of the second semester. And then students also required to pass research qualified exam at the end of third semester. And then students has to satisfy annual review by PRC. And then students also complete all of the research work required by supervisory committee. They have to submit acceptable in acceptable format for each thesis. So students required to publish one article in the Scopes Q1 and Q2 journal. Review article not counted. After approving thesis TEC committee, students can submit their thesis and then they will defend their PhD. Okay, so our research area in PhD level, we divide into 4 areas. Chang-Keun give a very detailed introduction in this research. So one of the main area, energy generation and the conversion and storage. So this area, we have very active research going on, like solar cell, photocatalytic hydrogen generation, also lithium battery, and supercapacitor. And then we have also another big research area, environmental protection, remediation, and resource efficiency. Also, this part also Professor Chang-Keun Lim give a very detailed description. And then also third research area for PhD program, PhD students, like process design and simulation. And the last one is the functional materials. So here's one of the example I would like to mention. So our PhD students working on this topic, innovative materials for heterogeneous catalysts, photocatalysts in Professor Stavros Poulopoulos group. We have also students working on also battery research area. Okay, so this is the last slides my colleagues already shown. So our faculty is working on all of the different research areas. So we can divide 4 areas, major areas. One is the energy, is the biggest area. We have also environmental, also bio and materials. So if you have any questions, please ask me. So this is our PhD program in chemical engineering. I'm happy to answer these questions. I'm done. Thank you.
Dear professors, thank you very much for your presentations. It was very, very informative. I'm sure that we could use even this recording to help the future applicants to know more about the programs that the department offers. Dear participants, you can ask all your questions right now regarding the bachelor's, the undergraduate program, the master's programs, and of course the PhD program.
Thank you.
Yes.
Can I ask a question, please?
Sure, sure.
I'm Nazmul Hussain from Bangladesh. I'm applying for MS program on chemical and material science engineering in this session. I today already completed my submission. I have a question that approximately how much students are selected for MS in chemical and material science engineering? How much international students?
Usually, as I remember, 2 or 3 students we can accept in our department, in master program, in our chemical and materials engineering. So we can select only 2, but actually after then still, yeah, some seat is actually shared with another department also. Then we can select 1 more student as well. But basically we have 2 seats.
That means I'm applying for chemical and material science engineering. First choice this, and second choice is biomedical engineering. Third choice in environmental science engineering. My research interest, according to, if I not get in chemical and material science engineering, according to my choice, I will consider for the next options.
So you mean actually you separately apply that the program, or in one program there is a kind of research interest you select actually?
One program and others is research program. Interest.
Yes. No, then actually that's 2 seats is the maximum, yeah, in our the master program in CHME. So if you apply another program, but actually I'm not sure, in our department we have 2 programs for master degree. So one is MCHME and the other one is the MBME. So Stavros, actually, student can apply to both of the programs?
Yes, the student can apply for both programs, but he has to submit 2 applications.
Then, yes.
Because we have 2 separate committees, okay, working around during summer, okay, to select the applicant.
Professor, actually, there was an option that, are you applying any other university in Kazakhstan? I select no, because I'm passionate about Nazarbayev University. And then they ask other option on that, are you applying for any other department or any other course or program? That as I'm interested in chemical and material science engineering, then I skip this and I fill up that I'm only applying for this session. That's my question. And now I think that it's critical to get me chance in admission, as it's just 2 seats. I'm a bit worried about these things.
So the applying period is finished, right?
Yes,
well,
sir.
For international candidates, we have, it's 28th of February, so several days are left.
Oh, then I think actually you can, at least you can apply to the biomedical engineering or other department in our university also possible. But you say actually you're also interested in the biomedical engineering. So I can recommend you to apply in the biomedical engineering program as well.
Thank you, Professor.
You should, let me say, you should apply because the seats for international candidates are separate. Okay, so the number might seem low, but at the same time, okay, there is a smaller number of international applicants actually participating. It all depends on the participation, okay, and of course on the documentation of your application and qualifications. So anyway, my advice is apply. You don't have anything to lose.
I feel all the requirements, and I think I'm a competitive because I'm a bit good GPA, academic results, and other activities. Now looking forward, Professor, can you just share if it's possible how it's that shortlist will be expressed in March? It is late March or 1st of the March?
I'm also not sure exact the schedule.
You asked about the selection process.
Yes, sir.
The selection process will take some place somewhere from end of April till middle of July.
Well, actually, from this year that the international students actually have the evaluation, so the document evaluation and the interview will be separated actually. So international student earlier than the local student. That's why I also confusing exact the schedule.
Okay, thank you, Professor. But I'm passionate about some your research activities like biomedical engineering and chemical and material science engineering, because some topics are closely matched with Bangladesh, like heavy metal pollution. And I'm curious about graphene-based nanomaterial synthesis. And I think that some professors are nanomaterials or in nanomaterials and polymer science. Actually, I'm interested about those things. And biomedical engineering or 3D printing, as I'm a background of textile engineering. Meditextile is my course in undergrad program. So if I get an opportunity for MS program, Meditextile and such kind of like tissue development, these things will match with me. And so that I am curious about these things. That's it.
Any other questions or comments?
No, sir.
Mm-hmm. Okay. Yeah, from anyone else?
Hello, sir.
Yes, please, your question.
My name is Abbas. I just want to ask if we can get a copy of the file, the one Professor presented.
Actually,
there are so many points we can actually check in that thing.
Actually, you will receive the special email with the link to our YouTube channel where the recordings will be uploaded. I think it could be useful to watch it with the comments of our professors.
Okay, thank you.
Hello.
Hello.
My name is Harry. I'm also a second-year master's student currently here. My question is about the submission of the recommendation letter. No, international students, the deadline is 28th February, which is the coming Monday. So what happens if your referee is not able to submit the recommendation letter within that time?
Actually, you need to submit all the documents by this deadline. So if you have some troubles, you can write us, but this is the rule. So these are the deadlines for the submission of all the documents. Have your this person received the link for recommendation letters? Is everything okay in the technical part?
Okay, thank you.
Lunara, earlier, if I'm not wrong, we have had extensions in application deadline, right? So, Stavros, have we or have we not? Am I wrong?
But this is stricter now for international applicants.
Oh, I see. Okay.
Okay. If an extension will be given, I don't know. But regarding recommendation letters, Lunara, the process is that the faculty member directly submits the recommendation letter or not?
Usually the applicants, they give the email, so they write it, and then this person who gives the recommendation letter, they receive a link and they submit it by themselves. So it's important to check whether this person received this link. Does everything work in the right way?
But the student in general should not worry about this, because I suppose that before mentioning a name as referee, okay, he has conducted already the relevant, okay, faculty member.
So our master students, if apply for PhD program, the international students I'm talking about, they also submit before February 28th? Our department international master students.
For masters and PhD, the deadline is 28th of February.
How about our international students also submit like that deadline, before that deadline?
Well, this day should be the last one. So, dear Harry.
Yes, yeah, it's the same for everyone.
The same.
Dear Harry, could you please write us an email? Let me check it carefully with the admissions managers. So maybe there were some extensions or something like this. It's better to check everything before the deadline. So I'll write here our email. Please write us an email.
Right, I will. Thank you.
Thank you. Any other questions, dear participants?
No, thank you.
Okay. So if there are no questions, let me again thank our professors. Thank you very much for these very interesting presentations. Thanks to Arslan who tell us about his experience in the department, in the school. It's important to know how the perspective of the student. So dear participants, thank you for joining us today. Hope to see you all among our students. And thank you very much. If you will have any further questions, please contact us. Feel free to ask your questions. Thank you. Have a nice evening.
Bye.
Thank you.
Bye-bye.